Good afternoon, good evening everyone. I'm the team leader of Future Vision. As you can see, our team is consist of 4 members, and this is Vijay and Kakani. So when it comes to features, we have only 2 features. First one, lane detection, and the next one, traffic sign detection. The traffic sign detection includes 4 different kinds of things, like stop sign detection, and then speed sign detection, and parking sign detection. I don't know, it's like a question mark in there. I think it would be. So and then right turn sign detection. So, but when it comes to parking sign, we will have an SMS alert after the car is automatically parked. So this is the time efficiency pie chart of our team during this semester. So when it comes to the first pie chart, we spend 55% of our time for error handling because most of the time the new errors come on dependencies of OpenCV library or like this Python-based libraries, and then we fix one problem, and then like 10 new problems will arise. This way, we spend more time on error handling, and we've installed OpenCV and other libraries like more than like 10 times because it didn't work properly. So when it comes to the team meetings, like we've organized team meetings, and during team meetings we've done some brainstorming and just talking about the project. So like we've spent only 25% of our time for the hard work. And what do I mean by hard work? The implementation. Like we've tried the implementation. Like we saw the actual implementation of our code, and then we've spent for the documentation, for example, the presentation and other kind of documentation things during this semester. And I asked, and we gave a question to ourselves during the thing. So can we do better? I think you might have seen the project last time. We've done some projects like object detection thing, this kind of things last semester. But this semester we tried to use more OpenCV built-in libraries, or the libraries we've trained ourselves by using, like, of course, hard cascade classifiers and other graphical user interface classifiers. So this, and then we've come up with a merge of 3 courses. This semester, we've taken the digital image processing design course, the first one, and in this course, we've learned how to train cascade classifiers, for example, traffic sign detection or other, let's say, speed sign detection or other like lane detection things. And then IoT application system, and in IoT application system, we've built a project where we've used a Raspberry Pi, and we fixed the camera in, let's say, from higher angle, and then, for example, for the mall or other university or other buildings, and it counts number of people, how many people entered the building and how many people left the building, and all the time it saves the data in CSV format. For example, if we can give the limit to the our project, let's say an IoT application system, and then if the number of people are 50, if the number of people inside the building are more than number like 50, and then it's gonna send an SMS message to the manager, and then it's gonna send like a couple of emails to workers. So we've learned from classifying and training our data set, and came up with our, let's say, algorithms and digital image processing. And then IoT application system, we've taken how to work with, like, for example, other IoT systems, like sending an SMS alert, and then we've deployed all the things in vertically integrated project. So this is the main idea. So we've made our own hard cascade object detector using GUI, graphical user interface in Windows. Like, for example, we've trained this cascade parking XML, this cascade left turn, right turn, or stop sign detection, or speed sign detection, this kind of things. Like, and also we've learned object detection algorithms and object tracking algorithms. So in our IoT application system, as I have already mentioned, SMS alert feature and email alert feature. So this is the source code. We've both worked on Python, and then whenever we got stuck in Python, we've just changed the style to C or C++ during like most of the time doing some research online, of course in Google like GitHub repositories. So this is one shot from our project. So in this case, as you explained, when the car, let's say, detected the parking sign, and then it's going to send a message. In this case, we've used a Twilio API for sending an SMS alert. Just like as you can see, we've let's say signed up for the Twilio trial account, whether you can have 50 or 40 free messages, and it sends a message: the car has been successfully parked. That number in there just is given to you when you sign up for the website. So when it comes to challenges, we thought like we are in a loop of challenges when we deal with one challenge, like one problem, and then you were going to have like 20 more problems. So the most of the things like software related issues because of dependencies or Python library. If we install the library and then it's not gonna suit the library or Python programming language or other programming language, then battery related issues. When we do implementation, we run out of the battery so fast, and we have to wait at least 5 hours to test our project again. So when it comes to demo video of our project, it's not actually the results are not as expected as we are expected, and it may probably not as you are expected to. But okay, let's see the demo video. In this case, you cannot detect the traffic like line tracking like very clearly because of some latency from the camera and from the system. Like, it's a failure. But in this case, it seems like it's working properly, pretty well. This is the camera of it. So in the last case, you may have a question like how it turned to the left. But at that time, we just gave like the sequence of code to just turn left in that case. This is the end of our project. Thank you very much for your attention.